All right, thanks. I'm really glad to come here. I haven't been to Ohio State to give a lecture, I think, ever. And this is a place that has a very distinguished history in experimental economics and decision research, probably some other things I'm not even familiar with, so I'm really happy to be here. I'm going to talk about what we call a neurally inspired model of habit in consumer choices with two younger scholars who are at the University of Toronto who are really interested in kind of theoretical neuroscientific understanding of economic choice and empirical stuff. Okay. This is an actual sign, I think, from 1848. When Edison invented the electric light, this sign was often displayed. It says, you can see what it says, "This room is equipped with electric light. Do not attempt to light with match." And this is the first of three examples I'll give of what you might think of as a habit. And I'm going to try to language translate a little bit back and forth from economics to cognitive neuroscience language. And the way we think of a habit is it's kind of an overtrained action which historically has generated value, but which may be difficult to interrupt when the goal which the habit is designed to achieve, the value of the goal has changed. So this is an example, right? The goal is to get light into the room, and historically what you did was to light a kerosene lamp with a match, but this new technology does not require you lighting it, you just turn a key. And the point of the sign was that a lot of people tried to light the Edison light bulb. This is Jennifer Beals, an actress. She is pictured here in the kind of costume she wears in a television show. It used to be filmed near my old house called The L Word. And the key quote here is, L Word stands for lesbian, so it was a kind of a drama about lesbians in West Hollywood and all the interesting things that happened to them. And so she was what they called a power lesbian. Jennifer Beals as Bet Porter, that's her character's name, exuded professional competence and sexual dominance in equal measure. Her wardrobe played an important role in getting her to character. And so this is the so-called power lesbian wardrobe. It's basically a little bit androgynous and a little bit feminine, sort of a mixture. And she says in an interview, "I'd spent 6 years playing Bet and flirting with women and being with women as this character. Then she got a new job, L Word ended, and she was on a TV series called Lie to Me, and she's not a lesbian anymore in the show. She's a straight woman. And she says, when I got to Lie to Me, she wore the same kind of outfit. So that she was kind of typecast a bit on clothing, but not on sexual preference. She says, so when I got to Lie to Me, being on a set and being in a power suit, my brain thinks I'm playing a lesbian character." And this is, again, a kind of habit. In other words, she puts this outfit on and she walks onto a set, and after 6 years of kind of extensive training, her brain thinks I'm a lesbian. And if we had film of her on set, I would predict that she might have acted like a lesbian as sort of a spillover from her previous activity in terms of, say, flirting with women, even though that isn't her genuine sexual preference. Okay. Final example I call the shoe rack. So in our house, we usually come home and take off our shoes, and our shoe rack used to be over here. We painted our house, and they moved the shoe rack. We don't really care where the shoe rack is, so the shoe rack's now over there. So the first night I come home after the shoe rack move, I walk over to the shoe rack. I get pretty much all the way, because brains are really good at sense-making confabulation. I mean, you think, who stole the shoe rack? I don't think, how stupid am I that I walked in the right direction? Then I quickly, a couple seconds later, think, oh, the shoe rack's been moved. I go and put my shoes there. And so notice again, the goal here is to put my shoes in the right place. But the habit that's been developed, it's as if the value has been kind of transferred to a particular motor execution, which historically has led to achievement of the goal. And so the second day, I walk again to the shoe rack, and I stop about 1 foot sooner. So this is a classic animal extinction experiment, basically, or reversal learning experiment. And then I go to the shoe rack, and it takes about 2 full weeks until I immediately go to the proper shoe rack. And so that's, again, evidence of, in this case, a habit in which the goal which the habit typically fulfilled has been devalued or switched, right? So it's no longer the valuable place for me to put my shoes is not here, it's there. And it takes 2 weeks of one trial per day for me to unlearn. Okay, so those are some examples of habit, and I'm going to try to be as technical as possible. And so the alternative to habit In fact, what I'm going to show you in the course, the central part of the talk is a little bit of an algebraic model that includes standard economic choice and habit as two things that are toggled between. The standard approach in economics is constrained utility maximization. I'm not going to, if you've never seen this, I'm not going to dwell on it much. It's not really crucial. It's just the other thing that's going to happen when people in our model are not in habit mode. The idea is that people have some subjective value or utility, summarized by a utility function. That may be conditioned on theta, which is, say, some information about the quality of products or the prices or where things are located on the shelf, right? And the workhorse model, this is just a simple one-period model, there's no dynamics, is that people maximize utility given this information subject to a budget constraint. This is prices times quantities. This is how much money you spend, and you can't spend more than your income. Okay. So I'm going to show you a model in which there are two modes of decision, which is model-directed or maximization, which is this, and habit. Okay. Let me skip Friedman-Savage. Actually, I don't think it's that interesting for many of you. Okay. So a little bit of a preview now that we've got the cold opening over. I'm going to give you it's a one-page preview just to kind of try to get the language into your head again about how we think of habit. I'll give you some background in psychology and neuroscience. I'll show you a computational model that'll also illustrate what we mean by a kind of computational model. It's, it's numbers that move around in a way that we think reflects a cognitive mechanism. And I'll say something about price elasticities, and then later other empirics, which I think are consistent with the habit model, but this is not, we haven't carefully tested a particular model. These are just interesting patterns that are consistent. Okay, here's the preview. So in computational decision neuroscience, probably the main useful thing that has been explored for about 10 years is the concept of two different types of choice, which is model-free habit and model-directed, MFMD. We'll sometimes use, I'll try not to confuse it with language, but we'll sometimes call this, say, goal-directed or maximizing. And what it means to be in habit mode is that you face a state, and a state is a choice set, like where to move in the house. Prices, the prices aren't going to matter for shoe racks, but it might matter for our consumers. Theta, which is sort of information, so that will include things like where the shoe rack is located, and locations, like, again, the shoe rack location. When you're in habit mode, you make the same choice as last time. Subject to one interesting constraint, which has to do with reliability. I'll show you in a minute. And why would you be stuck in these habits? Because they're fast. They're low effort. That's the good news. The bad news is they're inflexible. So sometimes you're going to go move in the wrong direction because we're kind of overtrained to move toward the shoe rack, or overtrained to act like a lesbian, or overtrained to try to light the electric light bulb. And they're also backward looking. So if we change the value of goods, which the habit has been successfully getting for us, we're not going to change quickly. There's going to be a kind of stickiness or inertia or habitual hangover. Okay, and the model-directed system evaluates actions by expected rewards and consequences. So if the consequences change, the model respects that and will reconfigure. It uses, by model, we're using the cognitive scientist concept of a model here. It's a little different than in economic theory. We mean a mental representation, like how do different motor actions or driving my car in certain ways lead to consequences, and how do I value them, and if I do different things, what happens, or if there's random chance events, what are the likelihoods of the chance events, and how does the change consequences. We're going to assume that people optimize, or in general use a softmax. And why would you use this model-directed system? It's really slow, and it takes so much effort to figure all these things out. The answer is it's flexible, so things change. Your model-directed system will help you make a better decision right away. And it's forward-looking. And the implicit argument here is that the right kind of mixture of these two modes is the way to live life. Okay, here's an example of what I mean by model-directed. This was I gave this talk at a few places, as you can see, and recently at RAND over in Manhattan Beach, or rather in, it's over by Santa Monica. And so suppose I wanted to go from Caltech to Manhattan Beach, which is a nice place to visit. This is an external representation from my phone of what we think of as a model-directed system. And the model is an actual path shown with blue lines. And this is a very sophisticated external representation. So before I had the phone, I may have had something like this in my mind I could manipulate, but it wasn't as sharp, it was harder to retrieve, and it didn't have all this great stuff on it, like red sections telling me that there's traffic. Okay, and what this model shows is all the possible routes from here to here with times on them, and where the detours are, the maps are marked in certain cities and things like that. So the advantage of this model derivative representation is I get in the car, I start to drive. If I'm driving along here, and I'm planning to go on this route is too red, so it's slow, I'm planning to go here, suddenly there's an accident, the software will automatically update and show me the accident, and it'll say, oh, it's going to take you 17 minutes longer. That's the advantage of model-directed or goal-directed behavior. In this case, it's externally helped, so it's going to work a lot better than my brain would. Okay, and the model-free mode would be as if I don't have this map. I've driven from Caltech to Manhattan Beach 179 times, every weekend for 3 years, and I get in the car and I just go. And if I turn the radio and it says, oh, there's an accident downtown, the habit just ignores that. So the habit system is going to be automatic but sticky, and it's going to make mistakes when there's unexpected surprises. Okay, let me clarify the scope. So when we think about habits, we have in mind the following types of things. Regular decisions that are made every day or week, so that habits are established by a kind of regular interval reinforcement schedule, basically. Food is an example. You have to eat 3 meals a day. You may eat the same thing for breakfast, or you may alternate among some menu. Commuting, like the example I just showed you, morning or bedtime rituals. Some kinds of consumer choice might work like this, like I showed at Caltech, and if I want caffeine, I either go and get a Diet Coke, or I go and get tea from one of 2 or 3 different places. I'm not going to consider habits that are induced by learning by doing or switching costs, which means I buy a truck, and it gets terrible gas mileage, gas prices go through the roof, and now I don't immediately sell the truck and buy a Prius, because it takes some time to do, or I might be waiting for gas prices to come down. And so certainly rational habits could reflect the fact that if you've been doing something a long time, you know how to do it better, or it takes time to switch. And I'm not interested in that for the purpose of this talk. And also, I'm not interested in biologically addictive substances, even though those will generate things that are habit-like, but they'll have other dramatic biological correlates like withdrawal tolerance, which you're not going to get from, like the shoe rack. When I walk to the shoe rack, and I realize I'm in the wrong place, I don't go through some biological withdrawal. Like, oh, I feel so horrible, and the shoe rack's not here, and I don't build up tolerance, and so on. So a lot of these, the things that are focused on habit are not as biologically dramatic, even though the word habit is often and sensibly used to discuss those two. Okay, so once you're in this world of thinking about model-free habit and model-directed flexible goal achievement, there are kind of 2 major questions. One is, how exactly do these habit and model-based systems work? And even though I use the word exactly, that's probably a mistake. I'm going to tell you what we think is kind of the state of the art, but there's a lot of questions that are constantly ongoing about these things. And by the way, in case I don't get a chance to say it, there are many literatures that study habits and use the word habit in quite a bit of different ways. Like there's literature on behavior change, getting people to break their bad habits like smoking, and there's some very interesting psychology studies where you query people about, what did you do today, what percentage of those were habits as classified in certain ways. There's the neuroscience literature, there's drug addiction, and there's some economics. So the first wave was evidence in psych and neuro from around the 1980s, establishing a concept of habit. That's the one I'm going to use. Then computational specifications came along a little bit later, and the modern neuroscience. And the most interesting question, I think, is, besides the basics, which are continuing to be figured out and explored, how do people shift between systems? And so the key number is going to be what we call a doubt stock, or a reliability signal. I'll say reliability signal, even though Peter Landry liked this term. What that means is, for everything we've done in the past, we're going to have a number which is our subjective valuation that's been learned over time, or maybe instructed. It could be some number we computed for the spreadsheet for a mortgage. And these choices that we made in the past are going to have reliability signals, which is essentially absolute prediction errors. It's whether the choices have been giving us a reliable reward or not. So it's a measure of volatility. And just to maybe guess what might happen. What's going to happen is when the reliability signal is low, that is, the choice has been reliable, it's been reliably rewarding, we're going to use the habit. When the reliability signal goes up, something happened that's unusual, it trips this kind of sensor, and then we go to model-directed code. Okay, I'm going to give you a little bit of background on things that are related to habit in biology, just to generate this is really sort of for economists. If you think that most of what people do is highly deliberative and calculated, you're wrong, and here's a few examples. These are some beautiful examples due to early ethologists, Tinbergen and Lorenz, and so on. Tinbergen, by the way, is the brother. Nico Tinbergen won the Nobel Prize in medicine, and his brother in economics. So that's pretty impressive, right? Brother, a two-sibling pair. And what they were interested in is what they called fixed action patterns, or essentially reflexes, but if you're an ethologist, I may be glossing over some important distinction, I'm not sure. And so here's a beautiful example. Male stickleback fish have a red belly and a blue-white back. Female sticklebacks have a grayish-green body and a swollen silvery belly. Okay? And the sticklebacks are very territorial, so the males kind of swim around a certain area, wait for females to come in and try to mate with them, and if other males come in, they fight them. And so it turns out that if you take a little piece of wood and you make a kind of caricature, a hyper-stylized caricature of a male stickleback, all you do is just make an oval, like a football, and you paint the bottom red. And you put that on a stick, and you put it in the aquarium, the male stickleback will fight it. In fact, if there's an actual other male stickleback and this caricature, it'll fight the caricature. Similarly for a female, if you stick this artificial female-looking, I know it doesn't look realistic to you, but the sticklebacks think, oh man, look at that, she's new. You put this piece of wood with a great belly on it, and you stick it in, and the males are like, hi, you know, how you doing? They're texting back and forth. And you put an actual female, and then they'll go after the fake one. And that's what Tinbergen called supernormal stimulus. It was like it sort of the exaggerated, sort of super perfect version. Okay, and the point is, these fixed action patterns, a lot of them show up in other kinds of species, and you know they're highly evolved and they're kind of perceptually sort of dumb. And so you could say it's kind of like factory installed habit. And I don't think they're even extinguished from reinforcement unless maybe under unusual circumstances, like if if the sticklebacks touched the female and you shocked them, they probably would learn, as in typical RL, to avoid the supernormal ones. Okay, fast forward a few decades to Anne Grable's group in a very seminal paper in Science, and they were interested in development of habit in mazes, in rats running mazes. So what that means is you make a little T-maze, you place the rat here. The rats are typically kept a little bit hungry, and so they go in and they're motivated to get the reward, which is typically cheese or liquid or something. And the way it works is they initiate the trial. Usually there's a tone or some kind of thing that tells the rat, okay, start. They run to here. At this point, they hear a tone, and there's one of two tones, let's say a high tone or low tone. High. And that means that the food is going to be on the left, or low, the food is going to be on the right. And then they get here and they have to decide where to turn. And if they turn left and there's food, they eat the food. If they turn right and there's no food, they made a mistake and the trial's over. And what you see here is a recording from single unit electrodes implanted in the brains of the rat, in striatum and in, I think in some other areas. And these are spike rates, and in seconds, where the seconds indicate when these events take place. It just takes 1 or 2 seconds. So at the start, you're seeing these spike rates here. When they get to the tone spot, spike rates here. When they get here at the turn, spike rates, and then this is when they actually turn and they consume the food. And so these are all different populations of neurons which are kind of encoding activity at each of these steps of the way. Okay. And here's where the habit comes in. So they do 9 training stages. There's a lot of training, a lot of training, a lot of training. the percentage correct, that means did they turn in the right direction? Basically, how well have they figured out which tone tells them where to go, right? It's the first couple of days they don't learn very much, and then boom, there's a big jump up to around 80%, and they asymptote around 90%. So they're not perfect, but they're getting 9 out of 10. And almost completely inverse of that is a drop-off in duration. So this is the trial duration in seconds. It starts out taking them about 5 seconds, and then by the end they can do it in about 3 seconds. And these are the durations. You can see at each of the different times, tone, turn, turnkle, drops. Okay. And so one of Graybill's ideas was that the habit here is actually a kind of chunked action sequence. And when the rat goes into the maze, they think, food. There's a prediction error and a reward signal that says food is coming, food is coming. And then going to the maze the first time cues a desire to execute the next step, which is to move and wait for the tone. And that kind of cues or habitually like primes the desire to go to the turn, and then that combined with the tone tells them where to go. Okay, one more picture from Graybill. And so this is 4 different epochs of training. This is the first day of training. This is where they're trained up to about 72% criterion of kind of performance, like they're getting the food most of the time, not quite an asymptote. This is an overtraining period where they're well-trained, they're down on the bottom of the learning curve, they're going very fast, and then this is the last day of training. And these are all neurons that fire as a function of some of the events: entry, tone, turn, consume, and these are striatal neurons, in case you're interested in the different populations. And what you see is early on, the redder, yellow and redder colors are more, these are the locations at which firing takes place. So the rats have this little cap that has the electrodes in it, and what this red and blue means is when they get to that point in the maze, you get the most firing. Okay? So initially, look at this for example, you hardly get any firing of the tone. The brain is like, tone? What's this tone? Tone? I'm not paying attention to this, I'm waiting for the food. Then they get to the turning point, and that's where you get the most activity. So all that encoding is kind of telling the rat, I need to figure out where to go. After a little bit more training, this completely disappears. So even though they're getting closer to the food, and actually now you get some activity in the ends. So you get neurofiring when they get close to the food. And what happens is that the neural activity backs up to the beginning. So now they have the strongest signals when they get in. And what the brain is telling them, we're now in a position where we're going to get fed, so I'm really, really confident that. And you get less activity here. And look at the final day, for example. You get quite strong activity initially, but it wears up very fast. As soon as they hit the starting gate, it's like, brain, shut down, I got this. And in here, this is very blue. So they're getting closer to the food, but not much brain activity. So that's what habitized brain looks like in this one kind of classic study. Okay. All right. Next big breakthrough, actually this came before Graybill, is Chris Adams and Anthony Dickinson in the 80s. And so they proposed the following idea, which was the marker of habit is a persistence of choice despite the fact that the rewards that the habit previously led to are gone. Devaluation of rewards. So let me say what we mean by that and then come back to the economics. So in instrumental learning, something's called operant conditioning. The idea is that the rat learns if they press a lever, they get some food. So they press and they press and they press and they press. And in one condition, they press 100 times. And that's training, but they're not what we would call overtrained. In another condition, they do this 500 times, typically over many days. And that's what we're going to call overtrained. In either of the two conditions, it's separate rats between subjects. After this training, either 100 trials worth or 500, they come out and they're allowed to eat as much as they want. But it's a trick. The food has a slight toxin that makes them sick. And this design exploits the fact that rats and people, are pretty quick to acquire a taste aversion to something that tasted bad. That's pretty persistent. Okay, and then the rat comes in and does a test. Okay, so if the rat is thinking kind of rationally, or rationally, it's using model directive. Its biological system says, I used to love that food, and I really love the fact that I could lever press and get fed, but now I don't want any of it. I'm not going to press a lever for something I don't want. That would be a rational model-directed system, right? And humans might do that, say, have better capacity than rats. On the other hand, if the rat is in habit mode, it goes in and says, wow, historically, pressing this lever yielded a rewarding and highly reliably rewarding stream of reward, and so I'm going to pick it again. And it may keep doing this until eventually the reinforcement's extinguished. Okay. And so in the, let's look at extensive training first. In the extensive training, after the thing has, the value control means it has not been devalued. It has not been devalued. It means, just keep going. The rats press about 6 times per minute. And even when it's been devalued, they keep pressing. That's habit. So habit is essentially the height of the gray bar relative to the white bar. If gray and white are just the same, it means the rat is pressing just as vigorously for stuff that's going to make it sick as for stuff that's not going to make it sick. And in moderate training, you do see a gap. And so the gap is the difference between model-directed override of habit. So the white bar means, oh, this is great, I'm going to get some food again. The fact that the gray one is lower means, to some extent, the habit is kind of suppressed. It's like, oh, stop pressing, that stuff takes turn. And so the existence, this gap indicates the gap between habit and model-directed, and here there is no gap because they were training means they're in pure habit mode. Okay, a couple more studies that illustrate this kind of just again and again. This is a ethanol habit in rats from this is jumping forward quite a few years. And here you can see, one open question, which we really don't have much intuition about, is how long do these kind of bad habits last? And of course, it may vary with individual difference parameters and with species and with ethanol versus pellets or lesbian outfits in movie sets. So you can see after 8 weeks, for example, they're in full habit mode. The devalued stuff is still pressed for, that is, it's worked for, at the same rate as the non-devalued. 4 weeks, you see a little bit, the habit's not quite as developed. In the first week, there's a significant difference between devalued and non-devalued. They're still pressing quite a bit devalued, so there's still some habit, but there's a gap. So not pure habit, closer to pure habit, pure habit. So this just gives you one smidgen of evidence about the time scale over which these habits may be developing. For the rats with ethanol, alcohol, it's on the scale of weeks. Here's a beautiful study, which I do not have the citation for, sorry. And another thing that's cool is there's substantial evidence that dorsolateral striatum is a region that controls habit, or signals in those areas are associated with habitual execution, and dorsomedial is model-directed. So if you inactivate dorsolateral striatum with a neurotoxin, you just inject this stuff that knocks it out temporarily. What happens is in medial, if you inject in the medial area, in the middle, devalued, non-devalued, this is pure habit, pure habit. Okay, it's true that inactivation means the toxin that knocks out activity in the region, it just poisons the neurons. And so it does knock down the level press, but the strength of habit is strong, which is these two bars are the same height. Habit, habit. But when you knock out the lateral, boom, the habit is extinguished. So we can actually kind of remove the part of the brain, or chemically disrupt the part of the brain which incorrectly executes this habit by pressing for something it really doesn't like. We can save them from their bad habits. And this is just an example, like many other things in causal neuroscience, where if we understand enough of the circuitry, we can causally manipulate things up and down. In this case, up in the sense that we erase habit, or down in the sense that we reduce the habitual responding. Okay. This is some work by John O'Doherty, my wonderful colleague, and Bernard Belin. And basically, these are regions, following on what I showed you before, in which dorsolateral lesions in purple tend to reduce habits in rats. Dorsomedial lesions tend to reduce model-directed choice. And if you do human fMRI with a similar paradigm, it's not poisoned food, but basically you give people your chocolate milk or juice, you take them out of the scan, they press, and get lots of this. Then you take them out of the scanner, you say, drink as much as you want. And so now we haven't poisoned them. What we've done is they drink so much chocolate milk they don't want to drink anymore. And so now, again, we devalue the chocolate milk now. It's not that they hate chocolate milk, it's poison, but they drink so much they really don't want it anymore. And when you look in fMRI, bold signal, you see a similar difference between the habit region, and the dorsolateral region, and the dorsomedial region. So there's a pretty striking rat human homology, at least for these simple paradigms where you'll ever press for more. Okay, onto the, we're going to leave rats behind. This is a messy picture from, again, from John Shinchimojo and Sang Muk Lee. And in Neuron, they were one of the first group to say, here's a computational model. Computational just means symbols. See all these symbols? See? Computational. And what the probabilities tell you is the likelihood that the animal is going to respond with a model-based response or a model-free response. So there's add up to 1. And the probabilities come from relative reliabilities. So the idea is if model-based mode has been generating rewards and model-free mode has been generating really wild rewards that move all over the place, you go to model-based. But when model-free has been generating wild rewards, you just use model-free. So the idea is that in this particular paper, I just wanted to show you what a computational thing looks like without any accompanying images. In this particular paper, the idea is that the brain is adjudicating or toggling back and forth between these two different control systems, and you can actually then, you can basically compute this number on a trial-by-trial basis, inferred from choice, and you run a regression and say, well, where in the brain is there a bold signal activity that's associated with this number? And you say this is a region in which encodes shifting control back and forth from habit, goal-directed. This is, I hope there'll be 10 or 20 more papers like this soon because it's just one paper, but it shows the general strategy. Okay. Important for economists. Many economists have talked about habit. As I mentioned, it's a concept that's used a lot. Campbell and Cochrane in macroeconomic and finance, they define habit as a utility function which the level of consumption minus X is your previous consumption, is the carrier of utility. So we would actually call this reference dependence or goal-dependent utility. Anyway, that's what they call habit, so I use the word differently. Another group, including Pollack and Becker and Murphy, you notice these are quantities, and see, this is T and this is T minus 1. So here, the way habit works is that the utility you get from consuming a quantity of A, that's the addictive good, in period T, depends on the quantity you had previously. And the dependence is thought to be positive. That's called adjacent complementarities. Basically, if you've been buying a lot of stuff before, you get a utility from buying more stuff. That is fundamentally different than how we think of habit. Habit is a shift of the cognitive mechanism. And in this approach, the difference is that this approach is forward-looking, right? So, for example, in this approach, at Becker and Murphy, very clear. Suppose, for example, you're told you're a cigarette smoker, and you're told that as of January 1, there's going to be a monstrous tax in Ohio on cigarettes. Or they'll be banned outright, or some terrible thing will happen, you'll be dropped in your health insurance. And the Becker and Murphy model, you would quit today. Because the more you smoke, the more you'll build up a dependence, and it'll be harder to quit in the future. In the pure habit model, some news about what's going to happen in the future doesn't enter in because it's backward looking. Okay. All right, finally we're going to see a computational model and talk about prices and speed up a little bit and to the more empirics. Okay, so the stylist model has, people are in two modes of choice. Maximization mode, they know all the different utilities for goods and they pick the best one. If things change, like prices or blockages on a freeway, they adjust instantaneously or at least based on their mental model. And habit mode, you're going to compute the updated reward value and then a reliability based on absolute prediction error. When choice is reliably rewarding, that means the reliability number is low, stick with your habit. When that reliability number goes up above a threshold, go back to utility maximization. Okay, so here's some equations. we're going to have two things which normally are kind of fused together in economic theory. One is the subjective values of utilities. Okay, so those are, you taste something and you go to a restaurant, you taste it, or you go on a commute and you have a judgment about whether it's better or worse than you thought. And we're going to keep track of what's called in this case it's going to be R. This is going to be the subjective perception of U. And if in period t minus 1 you chose C t minus 1 is what you picked in t minus 1. If you picked x, then we're going to update the subjective value of x by a weighted average of delta R times the utility and 1 minus delta R times the lagged subjective value R. So delta R is called the learning rate. If it's 0, you never learn. If it's 1, you're immediately reacting to what happened. And so delta R, a high learning rate we think is going to correspond to maybe general intelligence or perceptual sensitivity or something like that. And if you didn't choose X before, you just keep the same level of R. Okay? So the first two moving parts, utilities and R. Next moving part is the difference between those. That's the absolute value of the reward prediction error. So reward prediction error is R minus U, or U minus R. In this case, it doesn't matter. Basically, it's my expectation or anticipation is R, and I actually got U. If U is much better, I raise R. It's like, wow, this thing is really great. This is, it's a way of priming your brain to do it again. If U is below, you think, oh, this is horrible. This used to be really great, now it's not. And so this doubt stock D, or reliability, is going to be, again, a decayed version of the previous doubt stock plus the absolute value of the prediction error. So if your habit's good, and nothing's changing about the quality of goods or the quality of your commute, this prediction error is going to be small, right? There's going to be small numbers. The doubt stock is gradually decaying at a rate that's geared to this decay rate. And your doubt stock is going to go to 0, which means this is a good habit. Good, what does good mean? It means reliably rewarding. Reliably rewarding. And if you don't, for technical reasons, this does not come particularly right from neuroscience, but if the thing you chose is not X, it's something else, then you take the decay doubt stock for that choice and just add 1. So basically, the reliability is always going up. It's getting more, like if you haven't picked it in a while, it's getting more unreliable. And what that means is, if you switch from a habit to do one thing versus another, you don't get stuck in the new habit very quickly. You have to kind of learn that new thing is pretty good. And the way you choose is very simple. If the doubt stock is below a threshold sigma, so the habitual choice has been reliably rewarding in the sense of this absolute prediction error, do it again. That's it. Otherwise, utility maximize. And so one way to think of this is standard economic theory, if you take it seriously, is kind of implemented algorithmically, says, oh yeah, that's the same as a model-directed habit model, except with a reliability signal threshold of 0. So that there's never a habit so terrific that you don't break it and reconsider what to do. It would be like a hypersensitive, habit-reverse, habit-phobic creature. Okay, and this is going to generate properties that we want between the systems. If you're choosing something and the utilities are really good, the prediction errors are shrinking, the doubt stock is shrinking, the reliability signal is going down, then you're going to essentially shift from here to here when the reliability signal dips below the threshold. Yeah, this has been great. I'm going to do it all the time now. And if there's a surprise, a reward prediction error, so suddenly executing the habit gets something much worse or much better than it did before, then you are going to cross this threshold, bing, 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 bad habit, rethink, and then you're going to go to utility maximization. Okay, the next part's a little technical, so I'm going to go very quickly through it. And I wish we had a paper on this, but we don't. And I don't know when it will happen, but I can send you my slides if you're interested. All right, economists often have said what neuroscience would really impress us, if neuroscience could be defined, would be really impressed and we'd find it useful, which would be that you make kind of a novel prediction or help us understand something traditional in a new way. One of the most traditional things in economics, it's like vanilla, bland, mashed potatoes, no butter, no chive, no garlic, none of the stuff. No kale, no radishes. We had radishes at this posh place last night. I guess that's the cool new thing. Good luck with that. Very plain. It's called price elasticity. How many people know what that is? Okay, good. It's basically a price sensitivity. How much demand changes as a function of price. But usually it's done in percentage terms. So it's a percentage change of demand as a function of percentage change of price. So it's units free. Okay, that's the elasticity part. And so let's see if we can say something, because basically when I first heard of Anthony Dickinson's idea, a habit is when you don't adjust your behavior in the face of devaluation. I thought, oh, that's interesting. And then when I heard about the fifth time from John, I thought, oh, that's zero price elasticities. That's it. This is interesting. And nobody in the habit literature knew what these price elasticities were, and it was just, but it's kind of the same thing. At least we're going to make that connection. So the way we're going to study this is a very stylized way. We're going to think about just two goods, A and B, and we're going to assume that the utilities for the goods are constant until some point, tau, at which the utilities change by a perturbation delta x. So you're going to see a delta A for good A, delta B for good B. Okay? And we're going to typically think of these deltas as being positive, which means utility went down. Either the quality was decayed or the price went up. So net utility falls. But delta could be negative, in which case utility is even better, like the product was improved or it's on sale. Okay. All right. And then we're going to ask what happens when this change takes place. So if you looked at the utilities, it's like flat, goes up. Wow, things got better. And we're going to see if and remember, the habitual guys are not going to recognize that. It's going to take them a while to kind of realize, gee, I should buy this new stuff. Or it could get worse. And we'll see what happens with price elasticities. This is just housekeeping. Basically, we're going to assume that there's a mass of consumers and the difference in the utilities ranges from -1 to +1. That means there's people who really love A, and they're going to buy A no matter what. And people who love B, and then there are people that are in between, and they're going to be sensitive to prices and changes, things like that. Okay, so the first thing we get is, if you're inexperienced, you're going to have preference-based choice until later. So what this proposition tells you is, at all points tau less than tau star, the demand function for goods A and B is this. It basically means nobody's built up any habits yet. And these are the elasticities. Etas are usually used for elasticities. This is called the own price elasticity, right? It's elasticity with respect to demand for A as a function of delta A, conditional on delta B. Okay, and so this is negative. Own price elasticity is negative. That means if we raise the price of good A, fewer people buy good A. That's called the law of demand. It's the only law we have in economics. You're going to see me break it in a minute, or hypothesize how it could be broken. This is called the cross price elasticity. This is the amount of people who buy A as a function of the price of B. The price of B. And usually that's positive, right? Like if the B price goes up, I buy more A. Or I should say, the B people quit buying B and switch over to A. Okay. And so the point at which, this is standard, in other words, they're exhibiting standard utility maximization in every single textbook, up to a point which is a function of lambda and sigma. Okay, and so when you're going to go from maximization into habit mode will depend on the value of tau star. I'm not going to say too much more about that because it's not very interesting. One thing you get that's weird, although it's in the data, is there's going to be a number tau star given by this equation, and if the largest of the, so now we're in the mode where prices have changed for A and B. And there may be some adjustment, but it may depend on whether people are in habit mode and how strong the habits are and how big the price changes are and all kinds of things. It's going to depend in an interesting way. It depends on the maximum of the two price changes and whether the maximum is inside this threshold, pair of thresholds, delta star minus delta star or not. So basically, if one of the price changes is really big, you're going to have some response to price. You're going to have non-zero price elasticities. But if both of the price changes are small enough so that the max is in between this and this number, the elasticities are zero. Zero. What that means is the change in price wasn't big enough to trip the reliability signal threshold. So you don't respond to price at all. And interestingly, the size of this range, right, if you look at the equation and think about it a little bit, as time gets bigger, the size of the range gets bigger and bigger. What that means is if you don't respond to a smallest price change in the first few periods, the range of price changes in which you can respond grows and grows and grows. Like if you're stuck in a habit for a while, you never get out of that habit. And interestingly, there is some literature on this in marketing. It turns out that if you look at price elasticities with respect to small price changes, typically the estimates are kind of around like 10% of the price. You do see smaller elasticities. They're not zero, right? Like if I wanted to take the data, I'd make it zero, they're not zero. But they're a lot smaller than when they're above that range. So what it means is the demand curve does not have isoelastic. They're not isoelastic demand curves, even though that's the form that's assumed in almost every Homer problem in economics. So there's this flat spot in the demand curves, which is reflecting the habit. There's a weird shaped demand curve. Okay, final thing is, this is a curiosum. So this is a graph that shows possible price changes in A. Remember, positive means A is worse, costs more, or quality is worse. This is positive B. This is where B and A are both better. Here, A is better, B is worse, and so on. And in this gray zone, this is the dead zone. The elasticities are zero on the cross-price elasticities are zero. So if the prices are just not very big changes, nobody budges because of habit. Because of habit. And here you get something weird, which is opposite signed price elasticities. What that means is typically it's assumed that chicken and turkey are substitutes, let's say. That means if the price of chicken goes up, people buy more turkey. And if the price of turkey goes up, people buy more chicken. And that's the same. Anyway, if chicken goes up, price goes up, you buy more turkey. Turkey price goes up, more turkey. So the sign of the elasticities are separate. A lot of studies get weirdly signed cross-price elasticities. Like you buy more chicken when turkey's expensive, but you don't buy more turkey when chicken's expensive. And our theory actually predicts that in this weird zone. And the reason is that if one price change is big and one is little, you can get an asymmetry in how the price changes work, because a small price won't budge people and a big price will budge people. Okay. And there's another weird thing here, which is the law of demand is violated. And so here's what's going on there. Again, remember, the law of demand is the only thing we've got. And so income compensated price changes should lower purchases. And here the law of demand is violated for a particular weird reason. The reason is so the value of A goes up, and it trips this threshold. But meanwhile, and so if you're in A habit mode, you're paying no attention to the price of B. But if the price of A goes, if the quality of A improves, it trips the sensor, right? And now you say, oh, it's time to reevaluate whether I should buy something better. And it turns out B is much better. So the law of demand is violated because A got better for you, which tripped the sensor, and now you realize, which you didn't before, that B is really, really good. And so you get a very strange violation of the law of demand, that you can make A more attractive and then get the A buyers out of habit mode and then they buy B. And I don't know if that's really realistic, if we're going to ever see it in the data. John Kay was one of the few people to observe law of demand violation involving a model of the Irish potato famine with quinine. And it's something that's been studied quite a bit in economics because it's so quirky. If it did get violated, it would be a clue about some really interesting, malfunction or limit to the theory. But anyways, so if nothing else, I've showed you a very non-obvious prediction, maybe non-true as well, which comes out of thinking about these habits. Is if you're stuck in habit mode and a price change which actually benefits you pops you into this deliberative model base, you may actually buy more of the other stuff, even though the price benefits what you've been habitually purchasing. Okay. Let me talk about long-run, short-run elasticities. So there are many, many, many results. Every textbook has a discussion of this, and this is not puzzling. This is not an anomaly. I'm just going to tell you how habit modeling can help you think about it. If you measure elasticities in the short run, like you take daily fuel prices or weekly fuel prices at demand, as opposed to quarterly or annually, which one is called the short run, one is called the long run. Typically it's like a month is short, a year is long, or a quarter is short, a year is long. And you look at, say, fuel demand, you typically get numbers that are small, not zero, but small, minus 0.2, right? That means if prices go up by 10%, you buy 2% less gas, and the long run ones are much higher, like 0.5. Okay, big deal. Why? Why? So I had my RA read 5 economics books, and I said, send me passages that talk about long run, short run elasticity, which is in every single book. And some of them were just tautological, like one famous, I think it's embarrassing, it's not going to tell you who it is, but one thing says, short-run elasticities can often happen in a case where, like with drug addiction, where demand does not respond to price in the short run. But short-run elasticities is when demand does not respond to price in the short run. So, like saying, A happens when, in situations when A happens, right? So that's not helpful. But John Taylor, thank you, has a really nice paragraph where he says, habits that are difficult to break also cause differences between the short and long run elasticity. Quote, the short run, so for example, if you're taking microeconomics and your professor talks about short, you ask him, how long is the short run exactly and how do you compute that? And they'll say, well, it's usually 1 month. Well, how do you know it's 1 month? Like, does that come from some analysis, from a theory? But John Taylor says, the short run is a period of time before people have made all their adjustments or changed the habit. And the long run is a period of time long enough for people to make such adjustments or change their habits. So this is like great. He's using the word habit in a way that's empirically maybe quite forceful. But again, if you read longer in the book, it's like, oh great, we're going to see a formula for how long it takes to change habits. No such formula. And again, I should add that I'm not attacking economics in the typical way, which is what you said is really wrong, and here's why. It's like there's a missed opportunity to figure out how short run and long run works. And the way to do it is to think about something like habit, neurobiologically or formally, with whatever idea we have. So the idea is to kind of contribute to a standard question in economics that hasn't been considered really a very interesting question. Okay, and so this is our proof. It's very messy, unfortunately, analytically. The basic idea is there's going to be two numbers that are going up after a price change. There's two numbers that are going up. When one number gets below the other, sort of a window opens up. If the price changes in that window, that's when you switch from long run to short run. If the price change is really low, you never switch to long run. There's zero long run elasticity. If the price change is sufficiently high, you shift right away. So you could get very fast short run responses, very slow long run responses, or switches in between. And unfortunately, I don't have a nice graph to really show that, but this is the math. And so basically, when you set these two equal, that's going to tell you the point at which, for a price change of delta A, you transition from short to long. So you get a nice little formula. We haven't tested this. Intuitively, it seems to make sense when you think about it. But this is as far as we know, this is the first model of what it means to transition from long to short that's based on a concept of habit and persistence of habit. Okay. So other empirics. Okay, so that's the end of simple computational model. Tells us interesting things about price elasticities, which we either knew were true empirically but didn't know why, or we had a crude, undeveloped concept of habit and short-run, long-run transitions. Let me do these last parts fast. fast and we'll stop. I'm going to skip drugs, unfortunately, unless you really want to know. It's Shepard Siegel's famous Q experiments. Okay, there are a bunch of interesting factoids in various literatures, which I think are consistent with the existence of habit as we talked about it, but we don't really have a formal link between habits and what we do with pricelessness. These are just interesting facts. I think some of these are a little bit anomalous or surprising, although not that would convince a hardcore economist, although unfortunately I don't care about spending the rest of my life to do that. Ian can take over. Good luck with that. Before I talk about numbers, I want to show you a picture, 2 pictures. So this is from a Frontiers paper I found very interesting. So one interesting question is, what is the time scale on which habits develop? So I gave you a couple of hints, right, from the Graybill maze running and from ethanol, 1, 2 weeks, 8 weeks. I gave you the shoe rack, 12 days. Jennifer Beals, 6 years of dressing like a power lesbian. And so these are just some suggestions about the time scale on which certain things might happen. And the reason I like this is they dared, this is a cartoon, in other words, this is not data. They're just saying some things will happen on the scale of 10 or 100 trials, some will be on the scale of 100 or 10,000. And the nice thing is, habit mode is not just price elasticities. That's what we were able to prove. But we think of habit mode as probably being indicated by a whole bunch of different things. One is a reaction time asymptote. You saw that in the Graybill data, right? The RTs are just going to asymptote. Another is that early on prediction errors are positive and values are going to change rapidly, right? But if the learning rate is high enough, the prediction errors are going to start to shrink and you're going to asymptote value. And the other thing is that there's going to be a lot, habits are so effortless or low effort that there's going to be a lot of things accompany executing habits. For example, dual task independence. That means you can drive your car and listen to the radio or have a conversation or listen to books on tape, right? Uncontrolled intrusions, which means, if weird things happen, it doesn't deter you from your habit necessarily. This is, here's Adams and Atkinson, reinforced devaluation insensitivity. That's where we started off a few minutes ago in 1981, and effector dependence. That means the way in which you actually move could be very sticky. So there's a vending machine at Caltech, and the Diet Coke is in the top, there's the thing of 9, it's in the top middle, and I go and I press there. If they rearrange this and they put the Diet Coke somewhere else, it's possible if I was sleep deprived, I would press that spot anyway. Or if I would go to press, probably like the shoe rack, I'd probably go to press like, oh, wait a minute, where's the Diet Coke? It's here, right? But there would be this kind of interrupt and start. I'll tell you a quick story about this, which is we had some meetings at Tinder. I won't embarrass you by asking how many people know what Tinder is. Tinder is a dating app. Their motto is removing human, our mission is to remove human loneliness. And the founder, Sean Rad, said only 1% of the way there. Because Tinder is kind of known as a hookup app. You young people can explain. Okay. And the way Tinder works is it's double opt-in, which means if you're a straight woman and you want to be a straight man, you see pictures of straight men, and if you swipe right, you say, I would be interested in you. If you're interested in me, I'm interested in you. And so it kind of protects women. Nobody can harass you. If you swipe left, that person cannot harass you. If you swipe left, out. Swipe right, I'm interested. And Nick Whale, my friend who's over there, said, I said, what would be great to study habit would be if you reverse like the polarity, right? So that now, if you swipe left, that's good. If you swipe right, that's bad. And see what happens. This would be great. To study habit, this is the experiment I wanted to do. He said, you know what? I proposed that last year for April Fool's Day. I said, oh, we must do this. We must. Well, I said, legal wasn't too keen on it. Right. He's worried that people people would get confused. That's what we hope for. And then the question is how quickly they would sort of adapt. So this effector dependence is that kind of thing, right? If you're really used to swipe right, left, right, left, and you flip them around, it would take people. You could say in the screen, we've reversed, and still people would, for some number of trials, I don't know if it would be 5 or 3 days, would continue. So we'll see if we can get that done. Okay. So in our little graph, so as we think about habit mode, it's not just changes in elasticities, but it's a bunch of things which we can measure. So some of it is standard things in economics, persistence of choice, differences in own price across elasticities, but choice speeds, attention, purchase memory. We think people, if you're in habit mode, you might not remember as well what you did, because you don't need to remember in a way, right? What's the memory for? And some other stuff. Okay, this is this picture from Larry Squire and others, where he points out that skills and habits are often non-declarative or implicit. That is, you can't consciously talk about them, or you don't consciously remember. Here's example number 1 about limited memory for habitual choice. There's not much data on this that we can find. We're going to collect our own, including hopefully Tinder and maybe some other ones. And so this is a case where they ask people, each of these rows is a person, they ask people, how often did you check your cell phone in the last week? And they know the actual numbers. And this was not incentivized, so people weren't rewarded if they were accurate and stuff, so you could do it in different ways. And people said they checked 37 times, and they were off by about a factor of 2. They actually checked 85 times. They're a little closer on duration. They said, I think I would spend about 4 hours on my phone, and they're really 5. Here's another example. This is William J. Bennett. He wrote the Book of Virtues, which is very long, because he knows more about virtue than you. You should read his book and become more virtuous. Meanwhile, he likes to gamble. He said, I'm Catholic. Catholics gambling is not a vice. It's like, okay. And so he likes to gamble on slot machines. And over 10 years. And they said, you gamble on slot machines. Like, how do you do? He said, it's kind of, I find it's very relaxing. I sit by myself. Nobody bothers me. And over 10 years, he says, I came out pretty close to eating. Now, that is false, right? These slot machines have like a high takeout rate. Let's say it's 25%. And at 10 years, the law of large numbers applies to 10 years worth of gambling. So he's misremembering. And it turned out that the reason this came about, I think he either got divorced or there was some legal proceeding where some casinos were like suing him to get their money. And so these records came out from the casinos of how much he owed, and he lost $8 million. Okay. Now, this is not the best example for habitual degraded memory, because there's a lot of presentation bias and stuff here. But he wasn't shy about saying he gambled. He would just misremembered the number by a little. Okay. 2 more types of data. One is kind of a cute example, and one is search data. One thing that would be great to study habits would be, suppose you make a product unavailable for a while, kind of independently of quality, correctly as exogenously as possible. Right? Like in the lab, you can do that. And we might be able to do it in conjunction with a firm, like a Tinder or Uber or someplace like that that's open to experimentation. But it turns out that in London, it happens. And the question is going to be, if people seem to exhibit a habit because they've been commuting in a certain way, one thing that will happen if you're a habitual commuter is, it may turn out that another route is better, but you never find out. And in a way that's shown by our model. And so this is a beautiful study. So in London, there was a 48-hour strike. And importantly, it was a partial strike. So there's 3 things that make this a great quasi-experiment. One is that they didn't strike everywhere. Right? So some commutes, there was no strike, and others there was. So we can test whether, like suppose you see that the people who were on the lines where the strike was, they commute a certain way, and then 48 hours, they go back to an old commute, or they go to a new commute, and maybe we'll just like to switch. Or maybe there's a bunch of newspaper coverage about the strike that said, rethink your route, and even people who weren't affected by the strike rethink their route, right, something like that. So we have kind of a natural control group, the people who were on lines that didn't strike. The second thing that's cool is the tube map is not drawn to scale, as you might know. It was drawn by supposedly a circuit engineer, and the idea is to, actually a lot of these places are smushed together in London, but in the map they kind of stretch them out, so no places to, there's not overlap. And what that means is if this is your mental representation, remember we talked about model-directed, if this is your mental representation of the tube, it's wrong. And so if you get out, if you use a different way to check for a new route, or if you get out and walk, you may be generating updated mental model of the map. And the final thing is they have Oyster swipe cards. So most commuters have this swipe card and they swipe in and out. So I can tell, if person 149, 3XZ, BB 12, is commuting in the same way, and then when the strike is over, I see where they go to. And what happens is 5% of the uninterrupted riders after the strike switch to a better route. And again, it's hard to say that that's particularly irrational, but it's consistent with the existence of a kind of long-standing habit that was a little inefficient because they either didn't explore enough originally or they got locked in. And they do a little calculation. It turns out on the new route that they discovered, which is their new habit, they say 40 seconds a day, which isn't that much. But they do a little calculation of, if you value your time and your wage, blah, blah, they make it back down for calculation. It turns out to be 400 pounds. So one of the markers of habit is when people are forced to try new things, they'll often realize that they can save a lot of money. Because when you're in habit mode, you're not making that calculation. That's part of the definition. Okay, second thing related to that is high inferred search costs. So a number of economists have studied search models. What that means is, it's a little bit like expanded judgment in DBM, I guess. That means you have a data set, like somebody's going to get online and they're going to buy an expensive econometrics book. And they get on Amazon and they look up Woolridge econometrics. And it says, oh, blah, blah, blah. And then they get on books.com and they look at Woolridge. And you could infer you can write down a model of sequential search, and you assume that there's a search cost, like $1 equivalent to doing an extra search. It could be, it could be just time cost, or it could be aggravation, or regret, or who knows. And then you say, given the pattern of search econometrically, what does it appear that the search costs are? And usually you get a distribution. And so one example, I'll do these first. 3 examples that are not particularly habitual, and I wouldn't think there's necessarily candidates for habitual choice. Habitual choice will look like high search cost, right? Because you're always foregoing things that if you had searched would be really great. And these models are going to be rationalized by you're acting like, oh, I don't want to break my habit. That would be so terrible. So one study showed you can save $4 on online books. This is Matt Shum, my colleague. Another one said 50% of people don't search at all. In search through, what that means is they look for one thing. And they just buy that one. Don't do that. And for the people who did search a second time, the extra search value saved them about $1 or up to $19. And then computer chips is about $8. The thing is, it's hard to know if these are big numbers or little. Maybe these are quite reasonable. What you'd like to know is how long would it take you to do this extra searching and save this money? And so this is a beautiful study by Pinner-Sealer et al. They have shopping carts. They have radio frequency chips. And so they know exactly where the car is. So they have these sort of, maps of where the carts are going around. And they know, like, I go in and there's Danny yogurt, and I take a Danny yogurt. And next to it is Chobani yogurt, which is on sale. And if I looked at that and I spent 14 extra seconds, I can save a dime. Or some number like that. And so they compute the search costs that would justify how little comparison shopping people do. Okay, and the answer is $2.10 a minute, which is $126 an hour. And these are not like K Street lobbyists or well-paid people at Google, who are too busy. If it was Google, they probably have some app that delivers everything for them. These are regular shoppers in some store, and that sounds like a really high foregone value of search, which again is consistent with being so habitized that you just aren't bothered to look at other things on the shelf. There's some really striking numbers also from other studies involving inertia. These are generally things where people make a one-time decision. They often can change it either at any time or maybe on an annual basis, like with healthcare enrollments. And studies have shown that people can often save a lot of money. Like Texas, this is Ali Hortachu. In Texas, they set up a website specifically. You can buy electricity from different places. They specifically set up this website to help you save money on electricity. And they promoted it. Like they email people like, use our site to save money. We want you to save money on Texas electricity. And it turns out that the average person, if they took 15 more minutes, could save about $100 a year. So again, if you're a true believer economist, don't raise your hand. You would say, oh yeah, that's perfectly rational, it's perfectly rational. But if I had said it was $18 a year, you'd also say it's perfectly rational, perfectly rational. If I had said $5,000, I'd say it's perfectly rational, perfectly rational. I think I don't really understand what the phrase perfectly rational means. But some of these numbers I think are pretty high, and particularly Medicare and health insurance. So in some of these cases, it's clear that when you look at how little people shop and how big the potential economic advantages are, either they're in habit mode or there's some impediment that's getting them to not be doing as much shopping around as they should be. And by the way, almost every personal financial planner advice thing will tell you that you should be doing more of these things. So again, I don't think it's necessarily a moral failing or procrastination, although those things may all enter in, or confusion, but it could have to do with set it and forget it kind of habit mode. Okay, I'm going to skip drugs. So I showed you a neuroeconomic model of habit and model-based choice in which you switch back and forth depending on the reliability of the habitual choice in terms of reward. The economic part of it is, in neuroeconomics, we're kind of trying to do things that are economically interesting and neuroscientifically sensible and maybe make interesting predictions too. There's a formal structure, and we can say something about elasticities. The neuro part is that we got this concept of habit not from Gary Becker, like many other things that have been useful, but from ethology and neuroscience and computational modeling, like the Lee paper and some early papers by Nathaniel Daw and Peter Diane, for some of you will know. And the way we think of habit is that it's a type of processing mode, right? So I wouldn't say, I have a, I wouldn't say, I have a commuting habit from my house to back. I would say sometimes the choice I make is governed by a habit, and I choose the same thing because it's been reliably rewarding. And we also have a lot of interesting predictions about cognition that associate with habits. So most of the habit data does not look at things like, do you remember, if you're in habit mode, you not remember very well what you did, like, or what you bet. Or when you're in habit mode, how fast are you? Or when you're in habit mode, can you do dual task, multitasking attention tasks without any real interference? So there's a bunch of, cognitive markers of habit, which have not been explored very much. And finally, there's an interesting economic question, which is, it's quite possible that in a particular world where we had a Bayesian prior on the distribution of changes in price and quality, that you could tune a habit system with a particular learning rate, lambda, and a particular reliability threshold, sigma, so that you could show that you were rationally mixing habit and model variable choice, Bayesian rationally mixing it, given the priors on instabilities and non-stationarity. We haven't been able to do it. I think if someone will be able to do it, it would be done in a kind of toy way, and it would be great if a lot of economists thought this was interesting to do, but our focus is on the cognitive properties and where it's coming from in neuroscience and the ability to generate sometime soon some experiments that really simultaneously measure all these things that are markers of habit. Okay, thanks.
So we're going to take questions, and since the vast majority of you, I don't know, it seems crazy for me to try and point and name, so I'm going to let Colin field the questions, and off we go.
Yeah. So, didn't exactly present it like this, but it fits very nicely with sort of familiar parts of dual process models cognition. And I was wondering whether or not you were intending it to be construed in that way, or whether or not that was just a way of speaking.
Yeah, I mean, I'm comfortable with that. There are a lot of dual process models which share features and have differences, and certainly one general property often has to do with processing speed and simplicity, and that will generate accompanying occasional big mistakes, that type of thing. And the habit model will come fit. we, as a kind of marketing thing, I don't think I want to put dual process like in the title or the abstract, but I don't want to avoid it. And your point is well taken, actually. I think when we write our paper partway through the introduction, we'll point out this is a type of dual process model and there are others. And again, we think of this as a dual process model of choice, value of a choice in a particular way. So it's certainly quite different than judgment like economy system 1, system 2, and then there are a bunch of other models that say involve affect versus cognition or something like that, which I don't think would typically have on. But that's something we should be.
It fits better with implicit explicit learning. So the correct dual process theory, you get implicit explicit learning.
Yeah, exactly. Yeah. I think the early part of Habitual we kind of explicit, and then it quickly becomes, and the implicitness, like in the Squire picture, is that you don't really remember having done it. Another thing we are curious about, you probably would find it hard to articulate to another person how to do it. Because I said you have, how to drive a car.
Right.
Well, you get in and, you drive a car. So the implicitness actually is behaviorally interesting from the point of view of, say, training and transmission, which would be interesting in some places. I agree with you, that's a good point.
I actually had a related question. I was trying to map this onto a paper that you had from, probably 15 years ago or so, where you had a modified dual process model, and I might get your little 2x2 table off a little bit. But you talked about, I think it's probably sort of implicit, explicit, or automatic deliberative, as the columns, let's say, and then affective, cognitive as the rows. And I guess I was hearing your talk in terms of it being habits as being more implicit and more cognitive.
Yes.
Okay.
Yeah.
How do you think they're related to?
I think automatic, I'm glad I completely forgot about this, but it's coming back. I think automatic controls or explicit implicit are kind of the right, of the familiar distinctions out there, those are probably the right ones to that moment.
Do you think that are habits related to affect at all? So for example, there was when you're talking about preferences, it sounded a bit like Damasio's somatic marker kind of.
Yeah.
What do you think is the relationship, if any, there?
Well, you should blame George Lowenstein for putting that in motion. We were trying, what it is, we were quite solid in automatic control.
Yeah.
And also that was something that I made them seeing have a nice paper and people had, it's a little easier, if you think in terms of scarce resource, you can see how you would easily traverse the model. And we wanted to say something about emotion. And actually, on my sabbatical 2 years ago, I got a chance to finally catch up and read a lot about emotion, which I had been sort of not paying attention to. And I don't know that it would I don't see that how it would necessarily fit into habit. And if it did, like our habits more emotion-driven than the deliberative system, I doubt it. I mean, the whole point of habit is very little, really happens. Although it could be that there are habits that are like the fear, that for example, you habitually move away from a particular thing on campus because, a turtle wants or something like that. So,
Okay, although you related in, at least with some of the rat data you showed, you related in activation in some area of the striatum.
yes.
Which could be related to like Brian Knutson's work on on nucleus accumbens activation.
Correct.
So, okay.
I don't entirely agree with him on the mapping of affect, although he does have some data that are somewhat persuasive about that.
Is arousal in particular. Yeah, thanks.
I mean, to be honest, I think the legacy of model free and model directed through Diane or Doherty and so on is they're pretty mute on emotion. Mute in the sense when you get your phone, something is still going on, you just don't hear it. But I think that's something I would like to try to bring into the modeling lab as a good way to do it.
I want to push a non-mathematical description just to say, is it a gross simplification to say that a habit is a decision that's made without having to think about value, whereas where your model based you actually are? I'm thinking about this cognitively. So a person is presented with a stimulus, option A or option B, and they choose option A, and they do so because they have a history of some value from this object, but the choice itself is made, I think, your model would suggest is that no computation of value is necessary. There is no consideration of value. I just go with A as the output of this habit, this habit sort of model or the history that you have of this object. Is that a gross simplification?
No, that's exactly it. The only, well, it's a small, not a
Right, and you have the reliability.
There's reliability.
Yes. But I mean,
So the way to have it be executed, if you were to kind of build a machine, as we think of it is, you think about what I did last time, there's some reliability signal that actually could well be emotionally conveyed, like a sense of uncertainty or fear or that feeling. And if that's not too disturbing to keep it.
so if that's true, then as a psychologist, I would suggest that you're not necessarily studying dual process or dual systems in the way that we traditionally talk about them, because your dual system, your dual process here is, am I considering value or not? And the thing that determines whether I consider value or not is how reliable the signal, the if part of any if-then setup is, right? So if then is fairly reliable, then I don't need to calculate value. But if the presentation is stimulus, then the value that comes after is strong, is weak, then I have to consider value. So in that sense, you don't need any of the baggage about whether it's conscious or unconscious or any of that kind of stuff, because they fall from the number of computations that I have.
Yeah, that's another way to cut it, right? Because it's almost absurdly simple, but that's its first shoe. But that also is why you're going to sometimes make mistakes when you could be forward-looking. And we can think about this a lot. And eventually, we want to do either imaging or something that would help us see something like where that value, that reliability signal is computed. I mean, Bernoulli in the neuron paper has a start. It might be very biologically dispersed. It might, like the steam conductance or your computer, your gut, that kind of thing. But you're right.
It's a bold prediction that you may not even get differentiated. You might get a value signal, but that's just a standard representation of the outcome that you expect. But it's not the computation of that value, the active engagement. I think your model says it would be less sensitive and also less robust. Just sort of get this diffuse signal. But this is good.
Yeah, that's right.
Do it, as opposed
That's
to-
right. You might be stripping away all the kind of identity or sensory things or something like that. I mean, if you were building a machine that didn't want this, and you don't want those clutter, you would get rid of it. And whether in the brain that means there's weak signals dispersed or there's highly centralized signals. I mean, we do know this stuff about the brain, but those are very simple tasks and simple animals, so we don't know that doesn't tell us much about human whole brain. Yeah, pretty good. That's very helpful. Yes.
What I find really intriguing and different about your model than lots of others, though, is what you're proposing the sigma is, the switch from one to the other, which is whether this reliability, because at face value, and certainly as psychologists think about this, there's lots of other things that can flip you from habit to more deliberative thought. And among other things, that would include the desire to be right. How much you care about this particular decision, which would all be independent, I think, of what you're saying is flipping the switch from one to the other. Or am I missing that somehow?
No. I mean, certainly,
You're actually making a
you can think of sigma as having a bunch of arguments in it, as a sigma function, like individual differences.
Okay.
So, for example, if you're very novelty seeking, you're going to be less habitual.
Sure.
If you're, if you're a perfectionist, it might be a sort of bias toward model-directed, figuring everything out. That would look like a low reliability threshold. I don't like adopting habits or something of that kind. One thing I've been very intrigued by is intelligence, because intelligence is interesting. And I'm always embarrassed to say this. Economists have discovered that not all people are the same. And they vary in measurable properties. And you can measure intelligence. There's a method we use in economics to measure intelligence. It's the cognitive reflection test. That's the measure of intelligence. I mean, that's the only one I heard of. You can be sarcastic. Anyway, and there's been a bunch of interesting studies indicating, I think actually probably really going to Stanovich and West and others, indicating that, simple measures of cognitive skill are associated with patience. That one goes back a long time. Higher cognitive skill or working more patient. And with like the propensity to choose consistently dominated, moderate choice, and things like that. And if you think of learning rate as maybe related to working memory and cognitive skill, then you're going to get some predictions about habit out of learning rate. The reliability signal threshold, I think, is maybe a little different. I don't know. You can think of that as habit proneness, and again, it might be affected by novelty seeking or drive for perfectionism and some other dimensions.
But are you also comfortable with like kind of within person changes from moment to moment? Like my sigma's going to change now because I really want to care about saving a lot of money. If you're talking about that.
Yeah, it could be. I mean, look, we just want to get a signal that's like not zero or infinite first from data, and then I think that the theory that derives sigma from some kind of sort of like design of a combined habit model reason probably would have a sigma in it that would not be fixed. That would be a function of, like if there's a big ramp up in environmental instability, you might then change the reliability of the signal to kind of tolerate, if you think you're having a certain amount of habits is necessary to economize them. And so, there's some evidence too from marketing literature that older people are much more brand loyal. And it could be that they're richer and they can kind of afford to be, but it could also be that the reliability signal, comparing habit to reliability signal is kind of effortful, and the reliability signal just goes up and up. So it's like, I'm much more habit prone, plus, I'm 68, I'm just going to I plan to do the rest of the same thing for the rest of my life. Why switch, right? So there could be something like aging, as well as other variables would influence that. And so yeah, I mean, we're thinking about that, but haven't been really. But intelligence can be very interesting because sometimes you think of habit as like cognitively lazy, but it's also being efficient. And if you have, you can be inhabitable a lot if the reliability signals are kind of set quickly, and if you're reevaluating in the right way. Alan Blinder, who was worked in the Fed for a while, was had a fantastic visit in New York at a sabbatical many years ago. We were talking about shopping, and he said, if I'm going to buy something up to $100 to $500, I look up the consumer reports, I decide if I want the low, medium, or high quality one, and I buy the one that's at the top of the list. And so that was kind of a meta habit, right? He had a shopping heuristic that was not model directed. Well, it was model directed, but he had a simplified heuristic, and I thought that's actually pretty smart. So thinking about habits is it's improved my life dramatically, but they're probably are a sort of sensible mixes of habits and unsensible, and that some of those might also have to think about clinical disorders. Like overthinking choice is not being habitual enough, and then other things you might be too habitual and too insensitive to environmental change and stuff like that. It's like a lot of the, one of the byproducts we are both interested in neuroeconomics, whether it's BDM modeling or this, or thinking about emotional properties, is going to be getting at kind of like the true structure of individual differences, or at least a different cut of individual differences that, that standard psychometric categories. Although I don't think we're going to those out, those just be different things that show up. So the habit proneness, as it's shown here, might turn out to be closely related to some other traits, or might be something. Yeah.
So on the prediction of the evaluation of the manual, so the essential condition there is that basically your habit to doing something A, and one day you found it's actually much better, but then you think, oh, I should evaluate other items. But that, do you have actually empirical evidence showing that, or
It's totally false.
Okay, and is it possible that the model can be formulated another way? Maybe there is also an asymmetric pattern of like this evaluation or like exploitation. Well, maybe when I see the A get better, I stick even more into A.
Yeah, No, that's a very startling prediction. I mean, well, you know, if I find some data, follow me on Twitter, it'll be the first to know. The example we had in mind was something like the following, which is, you know, you're commuting and you're commuting and commuting and commuting, and suddenly, you know, they open a new rail line, and because of the new rail line, your commute gets much better. But because your commute's better, you have this general sense of, wow, this, you know, this isn't actually in our model, so it's an intuition that's not in the model. But you break this reliability threshold and you think, oh, this is probably the time to think about other commutes in general, even though it is weird, because you're saying, now that my commute's gotten so much better, this is a time to shop around for more. And so intuitively, it seems to violate some more basic likely principle. But, I mean, look, having a far-fetched prediction that is, for which there's very little evidence, has never stopped the economists in the past, in some cases. So we figured it's just a, right now it's like, just kind of shows off that something really unusual could happen in a way you could kind of explain, but I doubt that we're going to see great data for that. If we do, it'd be a bonus.
Kind of following up on that, I was wondering if that doubt signal is asymmetric. I mean, if it's positive, it's going to take a lot more.
That's probably the right way to patch it. Exactly. Is that when there are positive reward prediction errors, that doesn't affect reliability as much as negative reward prediction errors. And that'll basically use for maybe even turn off this kind of weird demand effect prediction.
Now, if it makes it, if a positive makes it even stronger, then it becomes a problem. So if a brand exceeds my expectations every time, which is what we always say, right? Is that if they're always beating it, and they should beat it a little bit, but not too much, that now I revisit my whole decision.
Correct. Yeah. So I mean, basically, when there's a bunch of moving parts here, and so although I've talked to Peter, did all the heavy lifting early in the theory, and you know, sometimes you can build in a small change in the model and everything sails right through, or it's even better, something weird is fixed up, but I don't really know how it's going to happen.
It seems like it might be even more than just asymmetric, though, in the sense that, so if the expectation is positive, you can have not meet the expectation, but it's still slightly positive. And it may be that it's even more so a case that if you miss and it's actually negative, that's going to have much more of an effect on that perceived reliability or doubt than if you're just all within positive, but sometimes you overshoot and sometimes you undershoot. Right? So you could have the same amount of variability, but if it crosses neutral, that may be psychologically really different in terms of prompting reconsideration versus having things all within positive, but there's the same absolute value variability.
Yeah. I think we just got this data set from Nielsen, which you can get for a few $1,000s. That's unbelievable. It's 50,000 households and thousands of different product categories. And so I think we're going to be able to look at this somewhat carefully, whether there are asymmetries in response to different kind of price changes and threshold effects and stuff like that.
So just following up on that, so you fill up your doubt stock with a reward prediction number, right? And so does this mean if I'm selling you a yogurt, I can just increase the price by 10 cents every day,
Yes.
slowly until you don't realize it's $1,000?
Correct.
Okay.
Correct.
Yeah. So this also means that you should look at the other side of the market as well, because if I'm a seller, I know that you're this type of consumer, I would adjust my pricing strategies, right? And I know my competitor knows about this. There's so many complicated things going on.
Yeah.
So basically, if you're looking at the specific market, it's more elasticities. Elasticity is going to be documents to gains.
Yeah. So we haven't modeled the supply side extreme competition at all. But and it is true, one of the properties of the model as we get it down is that if you have basically suppose you want to raise prices by $1. If you raise it slowly at a slow enough rate, you'll never lose a customer. And if you raise it quickly, you'll lose a bunch of customers. So there's a kind of similar to like a what's it called in psychophysics, like a just noticeable difference in price through the reliability.
Yeah, but then it also depends on what is the share of your consumers that is sort of habitual, what is the share that is more model based. You can go back to this variance model from the 80s when there's surge in sort of this mixing strategy
And also, some of the moving parts are very similar to, in most of the search literature, I think I mentioned this a little bit, in a huge amount of search literature, and also in a lot of the market literature on price elasticity, you see what look like roughly two groups of consumers, who are very price insensitive and they don't search, and people who are good shoppers and they search and they're price sensitive. And some cases I've actually looked at segment analysis, I say, can you tell me whether there's two separate segments or three separate segments or five separate segments, and you typically get two or three, and then I kind of drop off for the next few segments beyond that, which is good. I mean, I don't know if there's two process models or three process models. Like two is just the minimal number beyond one that becomes interesting, but we don't know in terms of empirical classification whether you even would want to stop at two. Get two is the simplest number, which would be something interesting algebraic. Yes.
We're near the end, so this is a left field question. I'm a political scientist, so I don't know anything about economics or psychology. But I am interested in having...
You know about that?
Actually, we don't know about that either. So
What are you good for?
It's a difficult discipline to be in these days. But I am interested, though, in your larger intellectual agenda, which I've sort of been following at a distance for a while, in behavioral economics versus kind of axiomatic formal economics. And my impression from the outside is you've got all the data and the findings, they've got all the theory. Okay? And this problem is bringing the two together. And you're not going to convince them because data don't convince pure theorists. And they don't have to, and you're not going to be convinced by them because they don't have a good theory. And I guess the question I have is, I'm wondering whether you have been following at all the literature in cognitive science on quantum decision theory, which it seems to explain all the common Tversky anomalies with one well-founded axiomatic framework. And now it turns out, it looks like quantum game theory is going to do the same thing with behavioral game theory, predicting how people play Prisoner's Dilemma the first time around and so on. So that would be a very well-founded, axiomatically coherent, extremely elegant theory that explains everything the economists are struggling with. I don't know if it would help with habit or not, but I'm wondering whether you and the other behavioral economists have been sort of following this debate, and do you see the potential resource there for your guys' argument?
Yeah, potentially. I mean, I've heard Jerry Bussmeyer talk about quantum decision theory once or twice. One I remember more vividly, and I thought it was very interesting. It's I'm sure when I talk about neuroscience to certain economics audiences, they have the same reaction. It's kind of like, I just don't know quite what to make of this. And I read a couple papers and kind of poured through it, but I didn't really sit down and I wasn't being a good student about it, to be honest. But I do think there's some interesting, you do get a lot of interesting properties like order effects and these and the concept of like an entanglement could be a mark of a cognitive process, which is pretty plausible. And like you said, these aren't just wild ideas, they're wild ideas, but they've kind of worked pretty hard to show I can explain this effect this way, this effect this way, this effect this way, and there is an element that's unfalsifiable. That is falsifiable too. Like this thing should have happened, and it doesn't happen. So I've been kind of paying attention, but it hasn't been at the top of our list.
I mean, it does seem like the quantum decision theory people have penetrated psychology a lot more than the quantum game theory people have penetrated economics. And that seems like the next frontier, really, is for your crowd.
Well, and game theory is pretty interesting too, because it's quite natural to think that my behavior and understanding and James's maybe sort of combined or entangled in some interesting way that isn't standard. I have a belief about him and an iterated belief about his belief and stuff like that. That it could be some other mathematical. I mean, these iterated hierarchies, other than the simple ones we use, and get mathematically very obtuse very quickly. It might be that a quantum idea is actually very accessible. I mean, I usually tell graduate students, if you want to, if you're risk-taking, you want to be famous, read stuff like that. Because you're going to be the only one of the smart people doing it, and if there's something really delicious in there, then you can find out.
And you'll be famous.
You'll see. And there's enough things written. I think a few years ago, it was just scraps of stuff, but now you can sit down and kind of really almost teach a whole course and walk through at least a 10-week course. So hopefully some enough synchronized attendance.